Hello, calculus fans. We're going to do a little chemistry now. In particular, we're going to deal with the ideal gas law. The ideal gas law gives us a relationship between the pressure, volume, and temperature of an ideal gas. And for this problem, let's go ahead and assume that we have exactly 1 mole of an ideal gas. And then the ideal gas law will tell us that PV equals 8.31 T. We'll say that the pressure, P, is measured in kilopascals, the volume is V, it's measured in liters, and the temperature, T, is measured in kelvins. What we're going to do is find the rate at which the pressure is changing when the temperature is 300 Kelvin and the temperature is increasing at the rate of 0.1 Kelvin per second. We'll say that the volume is 100 liters and increasing at the rate of 0.2 liters per second. So the temperature is increasing, that causes the pressure to go up, but the volume is also increasing, that causes the pressure to go down. So we'll see what happens in the end. All right, so let's let T represent the time elapsed in seconds. Now at the moment that we're dealing with, we're going to have the temperature is 300, the rate of change of the temperature is 0.1, the volume is 100, and the rate of change of the volume is 0.2. Now we can write the pressure as 8.31 T over V. And while we're thinking of T and V each as being functions of time, little t. So we can apply the chain rule. And what that tells us is that the rate of change of the pressure with respect to time is equal to the partial derivative of the pressure with respect to temperature times dt by d little t plus the partial derivative of the pressure with respect to volume times dv by d little t. We can compute some of these partial derivatives and plug them in, and this is the expression that we get. 8.31 over v times dt by d little t minus 8.31 t over v squared dv by d little t. You see that in each case we have computed a partial derivative of p with respect to t and v and plugged those in here. Now at the moment that we care about, we'll plug in some numbers and this is what we'll get. We're going to get dp by d little t is equal to 8.31 over 100 times 0.1 minus 8.31 times 300 over 100 squared times 0.2. We've essentially just plugged in all of the values that we were given to say that at that particular time, what do we end up with? We work all that out, we get negative 0.04155. The negative is telling us that the pressure is decreasing. And so what we'll conclude then is that the pressure is decreasing at the rate of approximately 0.042 kilopascals per second. Okay, that's all for now.